Okay, so in our show today, we're going to have to get our calculators out because our calculators are going to help us find angles in a right triangle if we know two sides. That's the big deal. We're looking for acute angles in right triangles if we know two of the sides. So we're going to have our calculators out. We're going to hit the mode button, and we're going to make sure that we're in degree mode. Going to make sure we're in degree mode. That's great. We'll need that a little bit later. Because, see, in yesterday's lesson, we took a look at how to find a side. But in today's lesson, we get to take a look at how to find an angle. How to find an angle. So permit me the following. I've got some right triangle, and I've got a length, this is right triangle, I don't know, DOG, and GO is maybe 15, and DO is maybe 25, and I'm looking for the measure of angle D to the nearest degree. That's what I'm looking for. Measure of angle D to the nearest degree. And so we get to review everything we learned yesterday. And everything we learned yesterday says I take a look at the acute angle and I identify opposite side, adjacent side, hypotenuse. So from that acute angle, the opposite side is the one all the way on the other end of the triangle. The hypotenuse, that's the longest side, and the one that snuggles up to our acute angle, that's the adjacent side. And so I go back to the mnemonic device from yesterday, SOHCAHTOA. Helps us to remember what sine, cosine, and tangent are. And so I'm thinking to myself, I've got opposite, I've got adjacent, opposite, adjacent, opposite, adjacent. This is a tangent problem. Tangent of what? You can't just write tangent, you have to have an angle. Otherwise, that's just a color, folks. So we're going to add in, not add in, but we're going to write to be proper, tangent of angle D. What is the tangent of angle D? The tangent of angle D is opposite divided by adjacent. Opposite divided by adjacent. Well, now we run into a bit of a problem because we need some way to undo tangent. Some way to make tangent go away so that we can get the angle. And the way we do that is we bring in our calculator and we recognize that on our calculator, right above, I'll grab the mouse here, right above the tangent button in yellow, or whatever your color is, it says tan -1. It really says tangent to the -1. And what that really is, if you want to sound smart at a math party, that is the inverse tangent function. And what that means, the inverse tangent function, is that tells us the angle if we know the tangent. So angle D is the inverse tangent, the angle whose tangent is 15 over 25. And so I can just go to my calculator and I can find the inverse tangent of 15 over 25, and whatever I hit when that thing hits is your angle in question. I will take a picture because it lasts longer. Angle D is, and we want to go to the nearest degree on this, 31 degrees. There you have it. You can find an angle with a couple of clicks of a button. That's fantastic. I mean, that is good news for somebody. Somebody's going to be like, wow, I can find angles now. So let me see if I can get us a different problem. Right triangle, Maybe it's triangle pig. Angle P is the right triangle. And so this is, I don't know, 3.1, and the hypotenuse is maybe 8.9. And I want the measure of angle G to the nearest tenth of a degree. Nearest tenth of a degree. So again, I'm looking for angle G. And so for that acute angle, the opposite side is the one that's clear on the other end of the triangle. And the hypotenuse, that's the side opposite the right angle. And the adjacent side is the one that snuggles up to our acute angle. So I've got hypotenuse and opposite. So I go to my mnemonic device and I think opposite, hypotenuse. That's a sine problem. Because no matter how big I make the triangle, the sine of whatever angle G is always going to be the same. This is just similar triangles come back all over again. So angle G I can find using sine. Sine of what? Sine of G. And what is sine of G? Sine of G is opposite over hypotenuse. It is opposite over hypotenuse. So how does that work? Well, we go to our calculator and we say, I want the angle whose sine is 3.1 divided by 8.9. Because G is the inverse sine of 3.1 over 8.9. G is the angle whose sine is that fraction. And so I'm sure hoping, oh, there it is. Oh, there it is. And we're going to round appropriately. We're going to round to the nearest tenth of a degree. Looks like 20.4 to me. We doing okay? I sure hope so. So how does this all work? What kind of nasty question can I throw your way? Well, consider the following. This is a rhombus. In a rhombus, the diagonals are 6 and 10. Find the acute angle of the rhombus to the nearest degree. That's the problem. In a rhombus, the diagonals are 6 and 10. Find the acute angle of the rhombus to the nearest degree. This is a super problem because it reminds us of everything we used to know about rhombi. What do we know about a rhombus? We know all the sides are congruent. That's fantastic. We also know that the diagonals bisect each other. So when we say 6 and 10, what we really mean are 3 and 3 and 5 and 5. That's what we really mean. And we know that the diagonals are perpendicular. So this triangle is a right triangle. So if I'm looking for the acute angle of the rhombus, what I'm really going to do is find that red angle and double it. So how am I going to find that red angle? Well, the opposite side is the 3. The 5 is the adjacent side, and the hypotenuse is the side of the rhombus. So I've got opposite and adjacent. That, yes, I heard you, that's a tangent problem. Tangent of the red angle, I'll call that R for red. Opposite over adjacent. So now how do I find angle R? Angle R is going to be the angle whose tangent is 3/5. And that's exactly how I'm going to write it. I'm going to say the angle whose tangent is 3/5. And so R is 30.963, etc. Because I don't want that angle. I want double that angle. And so the acute angle is twice that. So I come to my calculator and I get, to the nearest degree, 62 degrees. We do not round until the very end. And the reason we do not round until the very end is because there could be rounding mistakes that happen in the middle of your problem. So you want to round at the very end. Okay. So one more. I'm going to bring in our friend the rectangle. And it's got diagonals look like this. And I have a side of 6 and a side of 8. And I want the angle between the diagonals. I want this angle. And I think to myself, yikes, how am I going to pull that off? And so the thought is, this is actually quite a doable thought. What if we were to draw that green dotted segment? Looks like it goes halfway to 8, doesn't it? Because it does. And how big would that green dotted segment be? Well, that'd be 3. And so I think we can do the same kind of thing we did with the rhombus. We can look at this triangle here, get a green acute angle, and double it. So what have I got? I've got opposite here and adjacent here. And so I'm going to say that the tangent of green angle is 3/4. So green angle is the inverse tangent of 3/4. And that is 36.869897, blah, 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 blah. So question mark angle is twice that. So question mark is, let's go nearest 10th just for sport, 73.7 degrees. So what should you know how to do? You should know how to label sides as opposite or adjacent or hypotenuse. You should know how to pick what trig function to use, and you should know how to use your machine to get the angles of a triangle. Awesome. Well then, we'll practice more tomorrow when we get together. Looking forward to seeing you then.